Hello team and welcome back to the channel. So this video is going to be really useful for people who are learning Kubernetes or preparing for DevOps interviews, because here you are going to learn some corporate level Kubernetes commands that are actually being used in companies. For example, you will learn how you can increase the size of PV, how you can add like storage to your existing persistent volume, how you can drain the worker nodes, and you can for those who understand, this is a really important task. Okay, similar to that we have so many different things, how we can perform the readiness probe manually. Okay, how we can forcefully delete pods if some pod is getting stuck or like not at all running, then how we can forcefully delete it. So like this, there are so many different commands that are actually being used for troubleshooting, for debugging, or for performing any specific task. Okay, so all those things I'm going to show you with hands-on examples so that you can learn in reality what kind of commands do we use in companies. So make sure to watch this video till end so that you don't miss out any of the things. Okay, yeah. Now with that being said, let's get started. Let us start with the all the different kind of Kubernetes commands. First command, before we execute first command, let me show you the project that I have deployed. You can see here kubectl get all -n web apps. Okay, so I have deployed this project. You can see it's a bank app project and it should be accessible over browser on this URL. Just to confirm, we can just paste it here and it should be working fine. So application is running fine, and with respect to this application we are going to test all the commands. Okay, so let me also run kubectl get pods -n web apps. Okay, first command that I wanted to show you, assume a scenario where you are modifying config map secrets or any other resource other than your deployment. In that case, for everything to start fresh, what you should be doing, you should be restarting this, right? How do we restart it? One option which is not suggested is like you can delete the pod and new pod will be created. But a better way and the correct way to restart your pod is using the rollout method. For that, you can execute the command like this: kubectl rollout restart and then deployment name, which is in our case deployment name is bank app. Okay, and then the namespace information. Once I do this, it has started. Now new pod will be getting created. This is the new pod. Okay, so new pod we created, and now whatever changes we did in other resources like config map secrets, those changes will be immediately applied here. Now one thing you'll be able to see, team, that when I ran the rollout command, here we were still seeing two pods, one pod that was running previously and one new pod that got created. The way that it's going to work, like when you run the rollout restart command, deployment is going to create a new replica set and it's going to ask replica set to create the pod. You can see here this was the old replica set and this is the new replica set. But your question might be, Aditya, why we are still seeing two pods? Basically, when you run the rollout command, so Kubernetes is going to handle creation and deletion of termination of the pod gracefully. That means until Kubernetes is going to wait till the time that the new pod that is created, it is started and it is healthy. Then only it's going to remove the old pod. So after it was done, when we ran the command again, kubectl get pods, then the old pod got removed because new pod started and it is healthy. Okay, so this is quite useful. So now let's talk about next command, which is basically roll back from a faulty deployment. Let us say that we ran some command kubectl apply and we did deployment of our application. Okay, basically we updated some changes, so we redeployed it, and when the new deployment was done, there were some errors, right? If you are seeing errors, first scenario is that either you can roll back to previous version which was working, or you can still stay and debug. So first option that we could go is basically roll back to previous version. So we can do that using kubectl rollout. Here also we could use rollout, and here specific command you have to use, which is going to be undo, right? And then deployment and name of deployment, which is bank app -web apps. Now what is going to do, this command is going to do, it's going to go back to the previous replica set. This is the new replica set and this is the previous replica set. Previous replica set, it got deleted, but using this command we could go back to previous replica set and the pod will be created, and the pod that will be created is the working version that previously was working. So I can execute this. Sorry, spelling mistake. Let me just correct it quickly. Deployment. Now we can see 𝗵𝐶TL get all -n web apps. Okay. So now it will be, you can see here, old replica set is again visible. So now basically using the previous replica set, a pod will be created which will work fine. Okay. Now these scenarios we have seen. Now let us talk about getting the full rollout history with revision numbers, like how many times rollout has been done. That information, if you want to get with detailed information, that we can get it using the command kubectl rollout history. This time we are going to use the history command, and whose history we want to check? The deployment, which is named as bank app, then namespace name, which is web apps. Now here we can see that there are total around 6 revisions has been done, 6 time rollouts has been done. Here you are not able to see the change cause. Why? Because if you want to see change cause, you have to add some information. Like basically when we perform deployment, we have to add the change cause. Once you add that change cause, and how it can be added? It can be added in this format. Change cause equal to whatever information you want to add, you can add, and then this information will be visible in change cause. Okay, so this is quite useful if you want to check the status of rollouts. Okay, now next command, let's talk about next command. So let us say that I have a requirement where I want to see all the mounted volumes. Okay, how we can see that? So first of all, let's say I'll run the command kubectl get pods -n web apps. Okay, so we have this, and the volume is mounted for this pod, right? So I want to see, basically my requirement is that I want to list the mounted volumes and check if the specific directory, which is /var lib MySQL, inside the this MySQL pod, it is mounted on the EBS volume or not. Okay, how we can check it? So for that we can execute command like this, and here we have to change the pod name. In our case, the pod name is going to be this. We can execute. Once you execute, this is what information you get. This is the volume on the EBS volume. This is the directory inside the MySQL pod, and total storage that we have given it is 9.7 GB. Occupied or currently being used is 213 MB. This much is free, that means 3% is only occupied. So this detailed information you can get about the mounted volumes. Okay, now next thing that you want to see, basically let me show you kubectl get secret -n web apps. So we have added certain secret which is named as MySQL secret. So whatever things that I have added inside it, if I, for example, let us say if I show you, give me 1 second. For example, this is my YAML manifest file. So we create secret in this format, where this is a data type variable that we have. Basically, you can call it as a key. This is key, this is value. So if you have this information, name of key, and you want to see the encoded value, this is the encoded one. So if you want to see the decoded value, you can execute a command. So we, at this point, we know that secret name is MySQL secret. So we can execute this command using JSON path, whose value will be data dot that whatever key, and we are decoding it also using base 64. Now it's going to show you the correct value, which is test@123. This is the password for our database that we have set up. Okay, so using this command, you can get the decoded values of the whatever secret data that you add. Coming to next thing, so next is quite important. Basically, let us say that as of now, as we can see, kubectl get pods -n web apps. As of now, we can see that our pod is working fine, right? And this has been running from last 5 minutes. So before that also, there were several pods running before that. So basically, before this pod got restarted, at the time before it restarted, whatever crash was there, whatever issues there, whatever errors were there, that we can check. Basically you can say log of previous crash before the new pod got created. So that is quite useful when you have to find root cause analysis, why the issue occurred, why some error occurred. So for that you'll be needing the logs of previous crash, right? You can get that information using the command 𝗵𝗃ctl logs -p and the pod name. So pod name is this and namespace information. Okay, now you can see that it is not found. Why it is giving? Because there was no crash before this pod restarted. So what we are going to do, we are going to manually do a crash. Okay, for that what I can do, I can see the way that I'm going to do this. Basically when this container got created, this container I'm talking about, so inside the Docker image, the default command that we have that is running is java -jar then app.jar. This is the main command, and this command will be having the PID of 1. So if I kill this PID 1, then by default this whole pod is going to crash. Okay, so we are going to execute that. We can run kubectl exec, and this command is also quite useful when you want to simulate a crash. Okay, and the pod name, which is this, then -n web apps, then -kill 1. I executed this, and now if I show you get pods, in a bit it's going to crash. Okay, already you can see it from ready state, it's already gone to like not ready, right? Okay, so this is how you can execute the simulate the crash. Now we want to see previous crash, and now you can see when I ran the command, this command kubectl logs -p for previous, we are getting the logs from previous crash, why it happened. So this is quite useful. Okay, coming to the next one, this was this command that I showed you to simulate the crash. That is also quite useful, and that was our 7th command. Coming to next one. So now what I want, you are already aware about the readiness probe and the liveness probe. In short, I can explain you that liveness probe basically checks if the container is running or not, while readiness probe basically checks if the application is running and if it is ready to accept traffic or not, right? So if you want to simulate readiness probe, if you want to execute it manually, you can do that. How we can do that? First of all, let me get the pods again, kubectl get pods fun and web apps, right? So I want to get the I have this name. So now I want to basically execute a readiness probe. How we can do that? So for that, what I'm going to do, I'm going to go inside the this bank app pod, and from there I'm going to execute a wget command on the localhost 8080/login, which is exactly the application is running. So if it gives us output proper, then we can confirm that application readiness probe is successful and application is running fine. So let me execute this, and you can see that we got the proper output. This is the HTML page that is working as a home page for our application. So we are getting that. That means readiness probe is successful, and we can confirm that application is running fine, right? Another thing, let's talk about kubectl get all -n web apps. Now, sorry. Okay, so now basically we understand that if bank app pod, this pod needs to connect to database, bank app pod is going to send request to MySQL service. Then this name, it's going to send a request to MySQL service, then this name is going to be resolved into the IP, correct? For example, where is it? If I show you correctly, this is the bank app pod, and inside this, in the URL of database, you'll be able to see MySQL service. This is the service name for the MySQL database pod, right? That means here if you are writing the service name, eventually in backend it's going to get resolved to the IP of the service, right? So how do we confirm that this resolution, this DNS resolution for internal services is happening or not? How can we confirm that? So basically what we can do, we can create one new pod. We can create one new pod, and inside that new pod, from there we can run a command to connect to this MySQL pod using the service name. So if we are able to connect using this service name, then we can confirm that this internal DNS resolution of this name is happening correctly. Okay, let me show you example. So for this, what I'm going to do, I'm going to create a pod quickly. Okay, and using my kubectl run command, I'm going to create a pod named MySQL client, and it is going to be using a Docker image of MySQL only. Why? Because we have to execute MySQL commands. Okay, and here I'm running the command to connect to the MySQL server, which is MySQL -h MySQL. Then this is the service name, this is the username we are defining, and this is the password. Remember that between P and the actual password there should not be any gap. So we can execute this, and let's see, and you can see immediately we got MySQL. So if I show you, if I run the command show databases, you can see BankAppDB, which is the actual database that we are using. So this confirms that yes, the service name of our application is resolving correctly. It means DNS resolution is happening correctly. So this command can confirm. This is kind of like we use it in case of debugging when we want to confirm the internal resolution happening or not. Okay, now what we want to see, so we want to basically see all the volumes and their mount path in the pod. Okay, for that we can execute this describe command. Let me show you. Give me 1 second. First, let me get the pods. Okay, now what I want to see, I want to basically get all the volumes details, right? Whatever volume is mounted on the MySQL pod, I want to see that detail and their mount path in the pod as well. Okay, so for that we can execute this command, and we just need to replace the pod name, which is in our case this one. We can execute this, and here we are seeing two things. First mount path is this one, which is the actual MySQL data, this pod mount, this database pod. It inside this we have this path. So this is mounted, right? Using this is the volume name with read write access. Then we have this. This is a specific default internal service account that is being used, and this is of just read only, and it is being used from API access. Basically, this service account will have a token that is going to be utilized. Okay, so mainly two volumes are mounted. Coming to next step, next we have the command to get service endpoints and actual pod IP. If you want to get the pod IP and the service endpoints, you can use a command like this. Here what we are doing, we are running the command get endpoints backup service. What is the IP of that pod we want to get? And from here we are getting this information. What exactly this command gave us the output. So this IP that you are seeing, this is the IP of the pod to which this backup service is connected. I can show you the details by, we can run the kubectl get pods -o void command, and this is going to show us the IP and the node on which the pod are running. So this pod that you see, it has the IP, you can see 151, and that is what is referred here. That means this backup service is connected to the pod which has this IP. Okay, so using this command you can get the endpoints as well as like that information, the IP of the pod as well. Okay, now coming to next thing. So next up we have which command? See all events in namespace sorted by time. For example, 1 second, yeah. So we want to see all the events. How do we, first let us understand how do we see the events. We generally see events like this. kubectl describe pod. Using this we can see the events. Events basically referring to what happened, like how or did the Docker image got pulled out, the container was able to start, all those information we will be able to see. So if you want to see all the pod, service, volume, probe, even kubelet events in chronological order, you can use this command. I can execute this, and here once again let me execute it in proper way so that it's visible properly. 1 second. Okay, now we are able to see everything. Here first of all, event reason, type, and the timeline is given. Object is, here we have pod, deployment, replica set, whatever has happened with respect to any resource, we are able to see that information here. And you can understand quite how useful this could be. If anything is failing, if you are having any kind of issues, you can check out the events at specific time, when the error happened, what time the error happened, with what resource, all those information you are able to see here. So this is quite useful. Okay, coming to next. Now comes the quite important and quite useful command that I'm going to show you, is how to perform patching. Okay, so let me explain you with respect to 𝗵𝗏𝗃. So now let's talk about quite interesting command. So basically, let us say that if I show you here kubectl get 𝗵𝗏, you can see that currently we are having 10 GB assigned to our application MySQL pod, right? In case you want to increase it, how you can do that? So there are prerequisites for that. First prerequisite is that the 𝗵𝗏𝗃 that you are using, it should be dynamically created. How we can confirm? So you can execute this command. Once you execute this command, if you see the output something like this, 𝗵𝗏𝗃 XX something, then you can confirm it is dynamically created. Second thing we need to do, for example, let me show you. This is the storage class file. Here, make sure that when creating a storage class, it has allow volume expansion true. If this is not added during the time of creation, you can patch it later also. How you can do that? You can use a command like this. Okay, before that, let us see the storage class name so that it is we could use it kubectl get sc. So from here we confirm your storage class name is this. You can see allow volume expansion. I have applied it. In case you have not applied, then you could use a command like this. Here just make sure you can see this is how you can allow the volume expansion. So here I can just add EBS SC. Okay, see, patched no change because I have already ran this command. So here it is working fine. And now in order to increase the storage from 10 GB to something more, we can execute a command like this. We can execute another patch command. Okay, here you can see I will change it to 15. Okay, and rest everything seems fine. You can see resource request storage this much, and 𝗵𝗏𝗃 name we are providing because storage amount, like how much it should be created, that we have defined inside 𝗵𝗏𝗃. So we can execute this and 𝗵𝗏𝗃 got patched, right? And now let us see the changes. kubectl get 𝗵𝗏. So after running the describe 𝗵𝗏𝗃 command, I was able to see something. Could not resize volume. Why? Because we have reached the maximum modification rate for volume limit. Basically, the thing is initially in my 𝗵𝗏𝗃, if I show you, size was 5 GB. As of now, the size that I'm having is 10 GB. That means around 5 hours ago or 4 hours ago, I have changed this, right? So I have to wait minimum 6 hours to for the again expansion or changing, right? But the command that I have showed you, that is going to be the same. So remember that. Coming to the next thing that we could do is basically how you can trigger a Crashloopbackoff error. Okay, so let us say that we have kubectl get pods -n web apps. So these are the pods again available for us. So if I want to trigger Crashloopbackoff error to this this pod, what we can do? So basically you can execute. Let me show you the command. Basically you can execute kill command on process 1, PID 1. You can see here kill 1. So this is going to kill the process ID process 1, the main process that is running. Let me show you. I can execute this. Okay, and now let us run this. So in a few seconds, now you can see the pod has went into crash loop mode. So this is quite useful when you want to set the crash loop error for some testing or for some debugging. Like you want to simulate this Crashloopbackoff error. Okay. Now let's talk about like horizontal pod auto scaling. Let us say that we have our pod. This pod, it will start to run in a bit. So we have this pod, and basically my requirement is that if the CPU usage inside the pod is more than 50%, then I want that number of pods should be increased in order to handle the load. So how we can do that? For that, you can simply run a command like this. Here what I have written, autoscale deployment backup. Backup deployment basically points to this pod, backup pod, CPU percent equal to 50. So minimum and maximum number of pods I have defined, which is 1 and 5. That means if CPU usage inside the pod increases 50%, immediately a new pod is going to get created. Okay, and maximum number of pods that can be created is going to be 5. So I can apply this, and in order to just confirm that it is applied, we can run the command kubectl get _n web apps. From here we can see this. Okay, as of now, like CPU is not at all utilized 50%, so it's not going to increase. But as of now, we have only one pod. Okay, and we can also run a describe command for this HPA to get a little bit more detail. Here, if you can get information, it was you can see here resource CPU on pods 26%. Okay, that means if it goes more than 50%, then only number of pod is going to get increased. Okay, next command that you should be knowing about is live streaming of pod CPU and memory usage. Okay, how we can do that? So first of all, just understand कि we can do this using this command. Using watch command, we have this. Okay, it is showing. You can see here, and it is not completed. It will showing live. But you need to remember one thing very clearly, that this works fine only because I have metric server installed. This is the metric server command. If I run this, since it is already applied in my cluster. In case you want to use the watch kubectl top command to see the live usage of RAM and CPU of the pods, make sure that you have executed this command, which is going to set up the metric server on your cluster. Okay, just to show you the example, here let me show you the pods of metric servers. This pod that you see, metric server, this needs to be deployed, and it can be deployed using this command. Again, it will be available in the documentation, so make sure to go through it. Coming to next thing. Now we have seen that let me show you. We have kubectl get pods -n web apps. Okay, talking about the MySQL pod. So if I want to back up the MySQL volume to local, for example, here let me remove this MySQL data folder. 1 second. So my requirement is that I want to take backup of MySQL pod volume. How we can do that? So for that, we can execute a command which is going to take backup on the local machine. Okay, this is the command that we are going to use, and we have to make sure that pod name is correct, and we can use the pod name, this one. And now it is going to take backup of this directory inside the pod. This directory that you see, var lib MySQL, that is the actual data folder inside with MySQL data will be there. So we want to take backup of this on the current directory in our local machine. That means on this local machine. I can execute this, and now let's wait for this. If I run ls command, you can see MySQL backup. So this backup has been taken, and this is available on our local machine. So this is also quite useful. Next, let me explain you a topic known as drain. So inside Kubernetes, generally we have multiple worker nodes. Okay, for example, we have kubectl get nodes. These are the worker node that we are currently using, right? Okay. Now the thing is that sometimes it happens that we have to take this node into maintenance. We have to add something, we have to upgrade something, like we have to modify a lot of things. What kind of things we have to do? For example, like we have to perform patching, and then we have to perform like EBS reallocation, then instance replacement, also sometimes kernel upgrades. So these are like maintenance kind of tasks that we need to do, right? So for that purpose, or in that case, what we have to do, we have to evict all the resources. For example, the pods and everything, we have to evict them from the current worker node, so that immediately they can be recreated on some other worker node, and on the empty worker node we can perform the draining. Okay, how we can perform this? So for that you can use a kubectl drain command. Let me show you. For example, let's say I want to perform draining on the let's say second worker node. So I will first make sure that I have correct name available, which is this one. So from here to here I will copy, paste here, and now it's going to perform the draining. And you can see, now the thing is, you can see here evicting pods. These are the pods that were deployed on this worker node that are getting evicted, and now all these pods and other resources are going to be deployed or recreated on some other worker node. You can see last we are seeing drained also. That means it is now all those resources are gone. So draining is quite useful when you have to perform some kind of patching update or something like that. Okay. Now talking about next command. So here, first of all, let me see kubectl get, then get and run get all command. Get all -n web apps. So here currently you can see MySQL pod, it got evicted, I guess. So it is going to get created in a bit. So yeah, let's wait for this to come up. Okay. Now meanwhile, talking about if we want to restart all the deployments in the namespace. For example, all of my resources are inside this kubectl get ns namespace, this one. All my resources are currently deployed inside web apps. So if I want to restart, or basically restart all the deployments inside specific namespace, we can execute a command like rollout restart deployment inside specific namespace. Let me show you. If I execute this, so all the pods created via deployment, they are going to get restarted. You can see here deployment restarted for both of them. The next command is quite useful, which is going to help you list all the deployments with the specific image version. Whatever image version or image is being used for those deployments, that you'll be able to see. And let me show you the command. You can execute this and it's going to show you in detail. You can see for bank app we are using this image, version is v6. For MySQL we are using this image with version this. So this is quite useful. Next thing that I want to see, for example, let's say we have kubectl get pods -n web apps. We have these pods running, right? If I want to check which pod is running on which node, for example, I want to check for this. So how you can check it, right? So for that, if I show you, you could use a command like this: kubectl get pod, the pod name -n web apps, and then we will add -o void. This is going to show us exact this is the node name on which this pod is running currently. Okay. Interesting thing, team, you'll be able to see when I ran the kubectl get nodes command. These are the nodes available, and previously remember I ran the command to drain the node. 2 nodes I have drained, and as of now, after draining, they are not ready to schedule any pods on them. So if you want to schedule pods again on them, you have to execute the uncordon command. You can execute that, and yes. And now if I run the get nodes, you can see they are ready, and now pods can be scheduled on them. So now what we are going to do, we are going to perform the deployment of our, like previously our pods were failing, right? If I show you kubectl get pods -n web apps. So previously you can see as of now it got started. Okay, it's still in running status and there are restarts. So what I'm going to do, I'm simply going to perform the restart of all the pods. Okay, so for that I can run the rollout restart command for deployment. Let us run this. This is done, and I can check kubectl get all -n web apps. Second. Okay, so it will be running. I'm going to manually delete this pod and few other replica sets as well. So I can run kubectl delete. If I want to delete replica set, rs, and first this one, then this one. These are like already used. These are old replica sets which are not being used right now. This, and this also, and finally this -n web apps. Okay, most of them are deleted, and now we can check the status again. So slowly I guess it will start and application will be running in a few minutes. Okay, now coming to next command. So let us see that I want to force delete a pod. Sometimes it happens that some pod may stuck and it is not getting deleted. So how you can delete it? Basically, for example, let's say we have get pods, right? So these are the pods, okay? And I want to delete the first pod which is supposed to be deleted. So how we can delete it forcefully? For that you can execute a command kubectl delete pod, and we have to add force also, but before that let me correct the pod name, which is this one. Okay, here we are adding grace period equal to 0. That means initially when you delete something, it gets deleted properly, like grace periods get deleted, but here we are going to use force. Let me correct the command spelling mistake, I guess. Okay, I guess it got deleted already, and now here we should be able to see. So now all our pods are running fine. One more interesting command team that you should be knowing about is comparing your manifest against the live cluster. For example, very interesting thing I'll show you here, kubectl get pv. If I run this, we can see that storage is 10 GB. Okay, but when I performed the deployment, so initially in persistent volume the storage was 5 GB only. Okay, later on I added the using volume extension. So there is a difference between the manifest file. This is the manifest file .yaml. Difference is there between this and the whole setup or whole configuration that is currently running inside the cluster. So how do we check the difference? You can execute a kubectl diff command. Let me show you. Sorry, name should be manifest. Sorry. Now you can see persistent volume clean. Field cannot be less than the status capacity, right? Because that's what I told you. Initially when I performed the deployment of PVC, amount of storage that I gave was 5 GB, but currently the storage that has been created is 10 GB because we have upgraded it previously. Okay, so there is a difference.